All right, what we're doing in this problem, combining momentum with a previous topic, which is two-dimensional motion, projectile motion. So there's a collision. We have this bullet coming in. We'll call the bullet M1. The bullet is going to be M1, and then the block will be M2. Okay, so conservation of momentum says your total momentum before the collision or an explosion. You can use conservation of momentum for collisions, two things hitting, or explosions, two things pushing apart, like two people pushing away from each other on a frozen lake, or the lab we did where the two carts explode apart from each other. So the total momentum before the collision or explosion equals the total momentum after the collision or explosion. And it's an easy equation to remember because momentum is just mv. Now, in this problem here, this is our first one like this. Notice that the bullet, they tell us right here, the bullet remains in the block. So the bullet goes bam, and the two objects become one, which means that these two final velocities are the same. And then what else is true for this problem? M2, what's the initial velocity for the block? It's 0. Because what's the block doing before the collision? It's just sitting there, right? So that velocity is 0. So what we're going to have here is M1 V1 initial equals M1 plus M2 V final. Does everybody see what I did? These velocities are the same, so I just factored them out. It makes it a little easier. So then doing the algebra, V1 initial, because what we're looking for V1 initial, which is the velocity of the bullet before the collision. So V1 initial, when you do the algebra, will be M1 plus M2 V final all over M1. Now, what do we have to find? V final. A very common thing, I've heard this 100 times, where kids think that V final is like down here. Is that what we mean by V final? Before it hits the ground? What we mean by V final is the velocity, the split second after the collision. So the bullet goes into the block, but then what happens? The bullet block combo flies off the table with some velocity that happens to be an x velocity. So how do we figure out this velocity right after the collision? We're going to figure it out from this data here. The table is 1 meter high, and then the bullet block combo flies 2 meters horizontally. It's a projectile motion problem. Does that make sense? So what we have to do is figure out what is this velocity right after the collision. And it's an x velocity. So to do that, I'm going to draw a picture that I think is a little better. This one's kind of weird because it's at an angle. So I'm just going to redraw this situation. So here's what we got. We got the table like that. And then the block with the bullet inside. So it's like that. Boom, there's the block. We'll stick the bullet in there. Okay, bam, the collision just happened. The bullet block combo flies off with some x velocity that we're looking for. And by the way, what's the initial y velocity? 0. Has everybody got that? Look, because here's x, here's y. When the block leaves the table, if the velocity is only x, then what's the y velocity? 0. Okay, so it goes like this, like that. This distance here is 2 meters. And then the height of the table is 1 meter, which is going to be treated as a negative. Why is that a negative? Well, does the block go up 1 meter or down 1 meter? Down, because here's our sign convention. Our sign convention is this. Down is negative. Okay, so we're going to need some room. So we'll stick that up there. Erase that. Okay, so here's how you do this. Step 1, Oh, I forgot some other stuff. What else do we know? For projectile motion, x acceleration is 0. And what's the reason for that? Do you guys remember the reason? The x velocity, this x velocity here stays what? The same. X velocity stays the same, but what happens to y velocity? It changes because we have a y acceleration, which is negative 9.8. So this is the exact same thing we did a few months ago. Okay, so first thing we got to do is we got to find time in the air. Now you got a decision to make. Are you going to find time in the air with x data or y data? You can't use both. Y, in this case here, the data that we have, we're going to use the y direction. You don't have enough info to find time with the x. So here's how you find time. We're going to use the first kinematic, the first one that's on the list of kinematics. Y equals 1/2 gt squared plus vy initial t. What's the initial y velocity here? When the block leaves the edge of the table? 0. So t is going to be square root 2y over g. So that's square root 2 times negative 1, right? Our vertical displacement is 1, and it's negative because it went down. And then gravity is negative 9.8. So this gives us a time of 0.4517 seconds. So that's time in the air. So now that we have the time, we can solve for Vx, the initial x velocity. Yo. You have a question? So we'll stick that there. Okay, so now we can find Vx, which is what we need. We need that velocity. So look, same equation. X equals 1/2 at squared plus Vxt. What's the x acceleration? It's 0. So we're left with x equals Vxt. So Vx is x over t. The x is 2. And then time is 0.4517. So this gives us an x velocity of 4.43 meters per second. We take that, plug it in up here into our momentum equation, because that's what we were trying to get, is the V final. So m1 plus m2, you add the mass of the bullet and the mass of the block, and you get 0.258 kilograms. And then this is 4.43, and then the mass of the bullet is 0.008 when you convert it to kilograms. So when you punch in there, what you find out is the initial velocity of the bullet is about 143 meters per second. Make sense? Hey, so what made this problem difficult? The conservation of momentum is really not bad at all. The thing that happens is you run in, you're like, uh-oh, I don't have the final velocity after the collision. But wait a minute, I know how to do projectile motion, so you can figure it out from what you learned a few months back. So it's a perfect tie-in to, dude, look that's the way physics is. You know, physics is really not a class where it's like, oh, you can just focus on one chapter. You know, like notice we've been using the kinematics like every single chapter. So physics definitely pulls from previous chapters. Tomorrow what we're going to look at is a similar problem, but the old stuff is going to be conservation of energy.